Transformation of trigonometric functions. Question 3. Sketch a cycle of each of the sine function, state transformation from parent function. So these are sine functions here for you. The parent function is sine x. So don't forget to state transformations. So here let's first write down the transformation. Transformation here is what? Sine 2x. So it is horizontally compressed by a factor of half, correct? By a factor of 1/2. So that is the transformation here. What does that really means? Normally sine graph will have a time period of 2 pi. Now in 2 pi we'll have two sine graphs. That is what it means, right? Now it's horizontally compressed means time period is not 2 pi but just pi, okay? So that is what it is. So what I will do here is, as usual, as you know, our approach is like backwards working, right? Kind of I like that approach, and it's easy, right? See how easy it is. I'm making a big graph for you here, right? It should have been much smaller because the time period has actually shrunk, right? So don't go with the scale. So now this is our big graph, big version of the same graph. There's no vertical horizontal translation, so it will start with 0 and end with 0. That is one cycle for this. Now these kinds of questions, sometimes they will say draw the graph between a period of 0 to 2 pi. Remember that. But here sketch a cycle of each. So that is my one cycle, right? Now what really happened is, because I stretched it by a factor of half, now this one cycle time period is very important to mention. This time period is not 2 pi, it is just pi. I mean to say, it is not 360 degrees, it is just 180 degrees. In 360 degrees, we'll actually have two sine graphs. So sine 2x actually tells us how many sine graphs will be there in a period of 2 pi. If there is 2, there will be 2. If there is 3, then there will be 3 sine graphs or sine cycles within a period of 360 degrees. So I'm using the term 2 pi in radians and 360 degrees in degrees, correct? Now, because some of the students are working in radians, some in degrees, correct? Both are same. Now, so that is my graph, and obviously this is 90 here, right? And that is 0. And these are my 45 degrees, correct? And that is 90 plus 45, correct? So which is 115. No, 135. So okay, let me write 135. Okay, that's good. So 135 degrees. So that is my graph sine 2x. Now I've purposely made it bigger because I wanted to incorporate b in the same graph, correct? Right? So that is why I made it like this. Now let's look into, so that we are done with a, right? That's so simple, correct? One thing I've lost. Forgot to mention, and that is very critical, I would have lost 0.5 for this. The amplitude is 1, so we have plus 1, minus 1. Let me just complete it by saying x here and y here, correct? So that is the graph for a, sine 2x. Now let's go move on to b. b says sine of 2 inside and 2 times x minus 45. Now what is the transformation in this particular? There are two transformations here, right? One is the same as we had previously, horizontally compressed by a factor of half. So let me write compressed, horizontally compressed by half factor, okay? So that short form, but it means what I've written here. And the second is minus 45 degrees, right? So minus 45 degrees, it means translated how many units? Translate 45 degrees to right. Correct? So it is 45 degrees to right. That means every point actually, so first part is you'll draw a graph like this, that is one cycle, and the second part is that you'll translate every point here 45 degrees to right. So here we have 45 degrees, correct? So we'll move this point 45 degrees here, we'll move this point 45 degrees here, and we'll move this point 45 degrees here. Imagine that is my 45 degrees additional, right? So that is the first thing, and similarly I will move my peaks at this point, correct, which is 45 here, and this point will move to that point. Do you see how I have moved my graph, correct? So basically, instead of starting from 0, it really starts from here, right? Kind of like, and we get a peak here, and it goes parallel to this, and that is my 0. It comes like this here. It goes open. It goes through my 0, right, which is here. So, well, there's some error here, and it doesn't matter. And and then there will be a peak here and a 0 there. So let me just connect this up with this smooth curve, right? So there's something going wrong here, but this is my graph in blue, right? So let me just make it more bold and more worse than what it was. Okay, that's fine. So overwriting is not a brilliant idea here. But anyway, you get an idea that the whole graph actually moved 45 units to the right, and that is what this means. So if you have to sketch sine 2x, x minus 45 degrees, better sketch sine 2x first, like the orange graph I have done, and then draw your sine of 2x minus 45. Translated 45 units right as shown here, right? So I prefer to draw one original one and then translate. Phase shifts otherwise are very tricky. Now, of course, you would like to know what this point is. You need to add 45 to this. So when you add 45 to this, 4 plus 8 is 12, so you get 225 degrees. So it ends at 225. So its first wave starts like this. This really doesn't mean that there is no sine wave after that. There is. It just continues forever like this, right? But we are drawing one cycle, and just so we're representing this starting from here, correct? So, but sine waves, it will continue forever. So the domain is all real numbers, correct? But the range is limited to 1 and minus 1 in this case. Now, question C. Y equals to sine of half x. Now, half x is what? It's not that you draw half of the sine curve. It means again full sine curve, but the time period has changed, okay? So let me just draw a sine curve as usual, and that's my beautiful sine curve, okay? And there is no translation, so we'll just draw our axis. That's the first part. Now, when there is something inside, it only changes horizontal translation or compression or stretch, correct? So half over here says in a span of 2 pi, you will have half the wave. That is what it means. Half the wave in the span of 2 pi or 360 degrees. That means the time period has really stretched. So this is half the wave, which is 360 degrees, and full wave will be 720 degrees. That is what it means. I really wanted to highlight this thing to you, right? What does that mean, correct? So when you say k value here, this is my k value. Understand, k is half. So what is the time period t? T is 360 by half, means 360 degrees by half. Divide by half means 360 degrees times 2. That means 720 degrees is the time period. Perfect. Those of you who are doing it in radians, for that, if k is half, time period will be 2 pi, let me do it here, 2 pi by half, right? 2 pi by half, which is 4 pi, correct? So this will be 4 pi in radians, correct? That is how it is going to be. And 2 pi radians is half the cycle. Well, we have not mentioned any amplitude. If I write 5 here, how does it matter? Let me squeeze in this 5. A beautiful 5 there. And so we have this as 5 and that one as minus 5. Just change it to 5. How does it matter? So the beauty of drawing like this is it doesn't really matter, right? Whatever the value is there, just plug it in. But if you make a graph and a scale of 1, then you like to erase all this and then make a big graph. There's no point, right? 5, it means 5, right? It means the maximum is 5 and the minimum is minus 5. So that's how it is. At the most, you can add a couple of more points and then write down what these means, right? It was easy to die in radians, so I did it radians. It's not that difficult here also. We do 180 and we'll add 180 and write something here, right? So 8 plus 6 is 14, 4 and 1. So it becomes 540 degrees. So that shows your graph of 5 sine half x, correct? That's it. Now for you, let me give you an interesting question here. Now I would like you to sketch a function which is f of x is same as y, okay? Instead of writing y, you can write f of x here for this kind of a function. If I write y, you should write y there, okay? And x is the independent variable, x here. If I write t inside, mind it, then you should write t here. So I'll write down t for you, correct? So here I write minus, and I'll put half this side, sine of, within square brackets. Okay, half here also, how does it matter? Okay, I wanted to write t, but I wrote x, minus, so 45 degrees. So I'm not making it very difficult for you, it's kind of simple. So for 45 degrees shift, remember that part, right? So just practice this and see if you can get it. If not, let me know, write on your comments, and then we will see how to do it. Well, question number 4, 5 will help you do more complicated graphs. So we'll do some sketches and then we'll do some real graphing, okay? And then as a part, from a graph, we can write down the equations. We'll do all those things soon. Thank you.